Okay, this is the P4 paper from October 2022. It's question number 7. It's an integration question. Warn you now, this is a very, very long question. We're going to do part part 1, which is integration by substitution. And then we're going to do part 2, which is integration by parts. Let's have a look at part 1 first of all, integration by substitution. So we're going to try and integrate this thing here with a numerator, a denominator, and the dx. We need to replace all of those. I always tell my students to start off and focus on changing the dx first of all. In this question and in lots of questions, when we replace that, it's actually going to have an impact, in this case, on my numerator there. Let's just go ahead and do it and you'll see what I mean. So we've got part 1. The substitution is u equals e to the x minus 3. So if I differentiate, du by dx is just e to the x. So du is e to the x dx, or in other words, dx, which is what I wanted, is du over e to the x. That's going to replace that part there. If we now look at the original question, which was the integral of log 7 log 5, and we've got 4e to the 3x over e to the x minus 3 dx. Well, I can see here straight away that that's just going to be u there, so that can be replaced. I'm also going to replace the dx part here, and let's see what we get. We get the integral between log 7 and log 5 of 4e to the 3x all over u. The dx is taken care of by the du over e to the x here. And so this is what I meant. That and that are going to have an impact on each other. E to the 3x over e to the x, excuse me, is actually going to be e to the 2x there. So it's the integral between log 7 and log 5 of 4e to the 2x over u du. And so now when I'm trying to substitute in, it's e to the 2x that I need to replace. So we had that u was equal to e to the x minus 3, so e to the x is just going to be u plus 3. E to the 2x is e to the x, e to the x. It's u plus 3 squared here. Just take a little bit of time over that. Make sure you don't make any silly mistakes there. So now that's going to replace it, and I'm going to be able to do that. My limits, I'll need to look at those next. So technically I should write between x equals log 7 and x equals log 5. I'm not going to do that here, just in terms of time. I've got 4u plus 3 squared all over u du. What was I talking about 2 seconds ago? It's these things here now that need to change. They're my x limits, and I want u limits. So just to explain to the examiner what I'm doing, changing the limits then, I get that u is e to the x minus 3. So if I want to change log 7, e to the log 7 minus 3, well, e and log are the inverse of each other. They cancel each other out. This is 7 minus 3. This is 4, and then the same with the other one. So u equals e to the x minus 3 equals e to the log 5 minus 3 is 5 minus 3 is 2. Okay, so my original integral now changes to not between log 7 and log 5 now, but between 4 and 2. 4 u plus 3 squared all over u du. This is not an unusual version of this one then, just I'm going to multiply it out and tidy it all up. So u plus 3 squared is u squared plus 6u plus 9. 4 lots of that then is going to give me 4u squared, 24u, and 36 all over u du. So that's going to give me, finally, the integral of 4u plus 24 plus 36 over u. That's actually the integral that I'm going to now end up having to do. Okay, integrating that then, that doesn't take any time at all. They're all very simple terms. So So I'm going to get 2u squared. I'm going to get 24u. Yeah, 1 over u is log, so I'm going to get 36 log u, all between 4 and 2. As I say, this video is very, very long, so I'm just going to jump straight to the answer for this bit. You're basically putting in 4 in, minus putting 2 in, works out to be that when you actually tidy that bit up there. Okay, that's part 1 done. Why am I saying this video is so long? Is because part 2 now is even longer when we're looking at it, and there's some complicated algebra to get through. So your integration should be at a stage where you're doing past papers where you can recognize this then as being an integration by parts. And it's actually, not only is it an integration by parts one, it's one that we're going to have to do twice, and then we're going to have to do some shuffling around at the end of it. Probably easier if I just show you rather than talk about it. So we've got, for part 2, the integral of 3e to the x cos 2x dx. So it actually, in this case, again, because of the type of question this one is going to be, it doesn't matter which one I take as u and which one I take as dv, and it's very unusual to say that. If you've not seen one of these, you'll need to watch this video, go back and watch it again, knowing what I know now. So I know what this is going to end up looking like. I'm going to say u is equal to 3e to the x. I'm going to say dv by dx is equal to cos 2x. So differentiating that gives me the same thing, 3e to the x. Integrating that, the integral of cos is sine, so that's half sine 2x. I don't have any time at this stage to be fussing as to why those work out to be like that. If you're not sure with those, you need to go back and do some more work, really. So we're going to use integration by parts, which says that u dv dx is equal to uv minus the integral of v du dx. So if I plug all that in, the integral of 3e to the x cos 2x dx is going to be equal to uv, which is those two. So uv is going to be 3e to the x half sine 2x minus the integral of v du, which is always the bottom two. So tidying that up is going to be 3 over 2 e to the x sine 2x dx. And what we're always hoping for with integration by parts is that this integral is now something I can do or something a bit simpler. It's not at the moment, so what that means is that then I now need to focus on trying to integrate this part here, which we're going to do as integration by parts. So what I'm actually going to do at this stage is I'm now going to say, let's just integrate e to the x sine 2x dx. I'm just integrating this part here without the constant. I know that when I put it back into here, I'm going to need to do minus 3 over 2 lots of it, but we'll worry about that later. And say there is some quite nasty algebra to do, but let's just focus on actually seeing if we can integrate this bit here. So if we're going to integrate this bit here, we're going to need to do integration by parts for a second time. Okay, so if I'm doing that, I'm going to get u equals e to the x, dv by dx is sine 2x, so du by dx is going to be e to the x again, v is going to be the integral of sine, which is minus a half cos 2x, and then using this formula up here again a second time, I'm going to get that the integral of u dv by dx is equal to uv minus the integral of v du by dx, but using those terms there. Okay, so if I'm going to be using those terms there, it's going to be uv, which is e to the x times minus a half cos 2. So actually, let's tidy that up. Minus a half e to the x cos 2x minus the integral of v du, which is the bottom two. Well, the minus and the minus can cancel, so I'll get plus a half e to the x cos 2x dx. Okay, so now when we're doing this, remember all of this needs to be multiplied by -3/2 in there. So what I'm going to do is to write that bit out now again, as carefully as I actually can do when I'm doing it. So I've got that the integral of 3e to the x cos 2x dx is equal to, we had 3/2, I'm looking at this one there, we had that term, which is 3/2 e to the x sine 2x. And now let's just be careful with my signs here. This is going to be minus, well, let's do it like that, minus, and -3/2, so plus 3e to the x cos 2x, and then the minus and the 3 over minus 3/4 e integral of e to the x cos 2x dx. So as I said to you, just complicated when we're going through and doing all of this. And in actual fact, I think that's a minus there when we're doing it. That's a minus in there, that part there. And so now, ignoring all the algebra, ignoring all the signs and everything, this just, you say, well, I haven't done anything here. I've got to the same stage here. So this is the clever bit, that at this stage here, we see that this thing here and this thing here are the same as each other. So what I can actually do now is to take that over to the other side there. So if I take that over to the other side, 3e to the x cos 2x plus 3/4 e to the x cos 2x, the integral of, I'm actually going to end up with 15/4 integral of e to the x, just write that better, integral of 15/4 e to the x cos 2x is equal to, and at least the other two bits now, there's no integration in there anymore, 3e to the x e to the x cos 2. I hope I've still got some people watching this. Works out to be that then. But now, if I go back and look at my original question, I just wanted this to be the integral of 3e to the x. So if I take 5/4 out as a factor here, you've got 3e to the x cos 2x is equal to, again, whatever we had on the other side there, 3/2 e to the x sine 2x minus, so that should be a quarter there. No, it shouldn't, sorry, just leave that as it is at the moment. Yeah, minus the, where are we at here? 3/2 e to the x. Sorry, that should be over 4 there. Apologies, as I say, you can see just how complicated this is when we're actually going ahead and doing this one. 3e to the x over 4 cos 2x. Apologies for that if you were trying to follow that through and that wasn't working out now. So this very, very final stage then, if I wanted to have the original answer, I wanted to have the integral of 3e to the x cos 2x. So I need to get rid of this 5/4. So just multiply both sides by 4/5. If you multiply both sides by 4/5, we get 6/5 e to the x sine 2x minus 3/5 e to the x cos 2x. And at some stage through all that, we should have had a plus c coming in as my constant, but wow, yeah, look at how long that is. Wouldn't expect many people to get all the way through that. Our 100% for P4 people will get that, but there aren't that many of you out there. For the rest of you, just a question of going through, trying to keep your working out all relatively logical, Keep your handwriting nice and neat, and you'll get somewhere near the answer if you don't actually get the final answer out. But a very long and complicated question. Okay, hopefully that all makes sense.